All right, let's look at another definition. This is where we're going to talk about the span, right? So, because we're talking about subspaces and spanning sets, so the span or linear closure, if you will, of a non-empty subset S of a vector space is the set of all linear combinations of vectors from S. Okay? So the way we denote it is this way. So we have the S in brackets, square brackets, and we have the set notation, and it says S1 vector S1, excuse me, C1 times vector S1 plus all the way to C sub n vector S sub n, such that C sub 1 through C sub n are real, and the vectors S sub 1 through S sub n are all vector elements of S. Okay? So in other words, it's just all of the linear combinations of the vectors in S. Okay? And that would be what we would define as the span. Now, the span of the empty subset of a vector space is just the trivial subspace. Okay. Also, this symbolism here is not the only symbolism. So it's not, there's not just one way of writing the span. So sometimes it's written this way, and this way are also common in textbooks. Okay, just so you know. Okay, so now this definition here, now if we recall, before I had mentioned when we showed the solution, when we were writing the solution for a set of homogeneous, for a homogeneous linear system, and we wrote it as a linear combination of the betas. Okay, do you remember that? And I used the word that these linear combinations, these betas generate the set, right? Well, now we're going to use span. Okay, we described that set as being generated by the betas, and so now what we're going to do is we're going to call that the span of the set of the betas. Okay, so now we've got, you know, some more terminology to use. What else do I want to say about this? The only other thing too is here, the trivial subspace here, if you remember, we had in one of the proofs that this from the same proof with the betas, where we're talking about generated, that the span of the empty set is defined to be just the singleton set with the zero vector in it, because of the convention that a trivial linear combination, which just basically a combination of zero many vectors, adds to zero. Well, we'll talk about that later. We're going to introduce, the next thing we're going to introduce is another lemma, and we'll go forward.